Okay, graphing linear inequalities. I want to start this off actually with something that you might have done in the past and try to relate this as much as possible to what we'll be doing here. Just a quick review of your four inequalities. You've got less than, greater than, less than or equal to, or greater than equal to. And something you might have started off with in the past or have you done in the past would have been, just your simple, on a number line, x is greater than 5. Okay, so you go to the number line, put some numbers down. I like to just go one below that number, one above that number. And at 5, I'm going to put this open circle. Now, the reason why I put an open circle is because I don't want to include 5, but like on the number line, 5.1 would be bigger than 5. So I need to get something representing everything really, really close to 5. So on the number line, I end up shading to the right because all the numbers to the right are all the numbers bigger than 5. Now, what would change if I were to change that to, instead of greater than or equal? Well, if I were to take and to put this line underneath it, so put that line underneath that inequality, maybe. Okay, let's try this again. Okay, all it's going to mean is I'm going to include 5. So 5 being equal to 5 is okay, so you kind of fill that in with a dot. Well, we're not going to be graphing them on a number line. We're actually going to be taking lines, and we're going to graph them on the coordinate plane. So when it comes to graphing the line, I'm going to go through and I'm going to graph the line just like I typically graph a line, where I'm going to compare this to y equals mx plus b, get a slope of -4/1, get a y-intercept of -2. So I'm going to zoom in here real quick, go to my graph paper of... maybe I'm not going to zoom in, but we'll try our best, I guess. Okay, I'm going to go at -2 on the y-axis, and I'm going to go down 1, 2, 3, 4 blocks and over to the right one. So that should be at like -6, 1. Or I'm going to go up 1, 2, 3, 4 and over to the right one. And all I'm doing is I'm using a slope of rise, or in this case, rise would be down because it's negative, over run to the left, to the right one because of positive 1. Where I have to make my decision is depending on the inequality that I've got. So because of those two, I'm going to put a dashed line in, or I'm going to draw in just what would be a normal solid graphed line. Now, the reason why I put this circle on my number line for x is greater than 5 is it was kind of a boundary. It split my number line into the values to the right that didn't, or to the left that didn't work, and the values to the right that did work in my inequality. Well, that's basically what I'm doing with my line, is setting a boundary. So here we go. It is not equal to, so I'm going to put a dashed line. Well, now only one of these sides of the graph paper is my solutions, just like only one of the sides in the number line was my solutions. So I got to find a side to shade all these ordered pair. So what I'm going to do is I'm going to put in a point to test. It doesn't matter where you pick that point. I'm going to pick, here we go, 0, 0. I kind of missed on my little dot there. And I'm going to go 0 in for y, 0 in for x. So now -4 times 0 is 0. 0 minus 2 is -2. Is this true? Is 0 smaller than -2? No. So this is all my non-solutions. I'm not going to shade there. I'm going to shade to the other side. Okay, so let's try that again, just with a couple of vertical and horizontal lines, just to get some practice graphing those. So if I were to put those on the number line, here y is greater than or equal to 2. I've got myself a horizontal line at y is equal to 2. And because it's got that equals underneath it, I'm going to make that solid. And here, where are all the y values that are bigger than 2? Well, 3 is bigger, 4 is bigger, 5 is bigger. Okay, I'm only really worried about y because my equation only has y in it. Okay, whereas on this one, x is greater than -1, so now that's a vertical line passing through -1, but this time it's going to be dashed. Okay, and then I'm just going along the x-axis and I'm picking the values that are bigger than -1, so 0, 1, 2, and so forth. Okay, the purpose for the shading is the shading represents all the ordered pairs that work for our inequalities that we're given. I can't list out all those inequalities, so instead I put it on a sheet of graph paper. Okay, so let's try this another way. I kind of want to introduce you to another way to graph a line. You can more than welcome put this in, or go ahead, put that into y-intercept form. But what I'm going to do is I'm going to show, or slope-intercept form, but I'm going to show you how you get the x and y-intercept. Now the y-intercept we've done, so I'm going to start with that one first. But the y-intercept is basically any point that's 0, comma, well, your b value. So if I put in 0 for x, that goes away, divide by 2, y is equal to 4. So my y-intercept is 0, 4. So there's 1 point, there's my y-intercept. If it's the x-intercept, it's actually kind of the flip-flop of that. So I'll just use a for my x-intercept, and I'll put 0 into y. So now 4x plus 2 times 0 is equal to 8. That's going to go away. I've got 4x equals 8. X is equal to 2. So now on the x-axis, I got 2, 0. And what that's going to be nice is I only need 2 points for my line. Now because that is solid, because of the equal sign underneath my inequality, I'm going to go through and connect those 2 points. And there's my line. I tried to pick 0, 0. The only time I couldn't use 0, 0 for my x and y to test is when it's on the line. So I'll put in, I will when I get back there. There we go. I will put in 0 for x. I'll put in 0 for y. And I'll see if that's bigger than 8. So 0 times 4, rather, is 0. 0 times 2 is 0. Okay, 0 plus 0 is 0. Is 0 bigger than 8? Nope. So these would be like the no's, therefore it's the yes. It's called a binomial decision. It's basically if I've got only 2 options, no or yes. If I get no on one area, it must be yes on the other side. So that's how you can graph linear inequalities. You could find the x and y intercepts. You can also put it into slope-intercept form and graph the line that way too. It doesn't matter to me. I think that when it's written in this form, by the way, this is called standard form. This is quicker, but hey, whatever floats your boat.